Welcome back, folks. So in this video, I want to actually see how we can use this formula to actually evaluate a sum of an arithmetic series. So I have a series right here, and we were adding up 5 plus 12 plus 9, etc., etc. And the last term we're adding to that is 649. Alrighty, and we want to know what this comes out to. Okay, so one thing we need to know then is how many terms being added, because if we go through this little checklist here, we know the first and the last term, so we have this, but we don't know this yet. So how could we do that? Well, the way we're going to need to know is by creating the equation. Because, again, I know that this is A1, I know that this is A2 and A3. So I need to know what this is, basically. Well, I won't use N. I'll say A sub, I don't know, I'll use a different letter like K. Okay? It could be N, it doesn't really matter. Okay? Now notice that in this case, if you remember the last video, I said the first term doesn't actually have to be the first term, but as far as we are concerned, this is the first term, right? This is the first term that we are adding up. So yeah, I could start it as A sub 7 if I wanted to, but why do that and make my life more complicated? Okay? Actually, for some people, this might actually, the way that makes the most sense, probably actually, would be to make this A0. So I'm actually going to do that. A1, A2. The reason I like to do it A0 is because it makes it easier for me to create the equation. Okay, but we could do it either way. I'll do that way in green, and we'll use that as A1. We'll do that in blue. Okay, and we'll kind of do it both ways. And then we'll use a different letter here for A sub. We'll call this one A sub n, because it will be that K and N will be slightly different, right? And you can kind of probably tell that already. But let's create the equation then. So the equation then, so A sub K would be equal to, okay, so let's see, the 0th term is 5, so 5. And my common difference we can see is plus 7. So by the way, before you even try to use this formula, make sure you know it is indeed an arithmetic series, which it is, I believe, because it's adding 7 each time, at least as far as we can tell from here. Plus 7, plus 7. So our equation is going to be 5 plus 7n, or sorry, 7k in this case. Okay. If I'm using the first term, right, calling A the first term, then instead it would be A sub n is equal to, it'd be 5 plus 7 n minus 1, right? We just and again, if you're unsure, just double check that. Alrighty. By plugging in, in this case, I would plug in n equals 1. 7 times 0 would give me 5, so that checks out. In this case, if I plug in n equals 0, then okay, it'd be 7 times 0 is 0, plus 5 is 5. So this checks out. Okay. Now I need to know what term in the list this actually ends up being. So we're going to actually solve this. So I'm going to plug in 649. I'll do on this side now. 649 is equal to 5 plus 7 n minus 1. I won't go through all the steps here. I'll just set them both up and solve it on the side here just for time's sake. So take a second and solve this. Alrighty, so when I solve these two equations, on the left side here, I would say that I would call K 92. And on the blue one, we would say this would be the 93rd term. Okay, again, this is not actually that important because as long as we keep this in mind, the first and the last term. Okay, so this is really, I'll go back and fix this. This is actually A sub 92 or A sub 93. Again, this depends on if we started counting at 0 or 1. Again, I'm just showing you both these options because these are both kind of reasonable options. I think it would be kind of silly to start to call 5, say like the 17th term, although technically that is okay to do. Alrighty? Okay, so now that we have that, now we just need to figure out how many terms there actually are. Okay, so this is a common mistake. So that I just want to bring to everyone's attention here. So how many terms are actually being added? How many terms are we adding? Okay, so it totally makes sense for you to think this. So, okay, we're starting off. We start at 0, end at 92. And so the total number of terms we're adding is 92 minus 0, which is 92. I think that's totally reasonable. And likewise for the blue one, oopsies, sorry about that. On the blue one, you would do the same process. So again, start at 1, end at 93. 93 minus 1 is equal to 92. So you would think 92 terms. Okay. Let's talk about why that's not correct. And you can already tell from my voice that that was already going to be incorrect. But why is that? So we'll start with a smaller example where let's pretend we were going from A1 plus A2 plus A3 plus A4 plus A5, we'll say, right? If you're using the same logic, then I don't know why I keep doing that. I apologize. If you're using the same logic here, you would say, okay, 5 minus 1, and you would get 4 terms. But clearly there are 1, 2, 3, 4, 5. Okay. And so why is that? Well, when you are doing the subtraction, right, and we count on the number line to get from 1 to 5, how many steps do you have to go? Well, you have to go 1, 2, 3, 4. So you do have to take 4 steps. But when you're subtracting, you're not counting where you started. But when you're adding these terms up, you do want to count the where you're starting at. So you do need to essentially take the difference and then plus 1 more to account for that. Okay. Now it's actually easier to see when you do start off at 1. So that is one benefit, I suppose, to starting your counter off at a sub 1, because then, well, how many terms are there from term 1 to term 5 is, well, of course there's 5. So how many terms are there from 1 to 93? Well, 1, 2, 3, 4, all the way up to 93 is 93. Okay, so in this example, there are actually going to be 93 terms. So we actually do have 93 terms. And so let's just throw it into our formula. And so we have 93 over 2 times the first and the last. So the first plus the last is 5 plus 649, which is that. And we end up with, let's see, 5 plus 649. That's going to be 654 times 93 over 2. And we will get this fairly large number, which makes sense. That's a lot of terms being added up. We get 30,411. Let me double check this actually. Okie dokie, sorry about that. I thought I might have misclicked on my calculator here, but that does turn out to be correct. 30,411. Okay, so that is the value of this sum. Okay, I do want, before we leave, I do want to point out one maybe elephant in the room. You might notice, like, well, wait a minute, dude. There's 93 terms, so that would mean that, well, since it's an odd number, you can't pair up every single term. There's going to be one term which would be in the middle and therefore, unpaired. So that's actually going to be totally fine, and this formula still works for that. And why is that? Well, in this case, well, we won't show it with this case because the number's huge, but let's pretend we were just adding up, well, 3 terms, okay? This would still work. So let's pretend I want to add up just, A0, A1, A2, and using the green counting method. So this would be 5 plus 12 plus 19. Okay, well, I'll add the first and the last, and we'll get 24. The reason this still works out is because this number in the middle is always going to be exactly half of it, because again, you're subtracting. Well, in this case, you're adding 7 on this side, subtracting 7 on this side, so it ends up being the same. But since there's only one of them, it just ends up being half of what the other sum would have been, right? So hopefully that makes a little bit of sense, and you'll see that this still ends up working out. Okay, so again, what would have happened is the 5 plus the 649 is 654. What was it? 12 and 642. Those would have also been 654, and you would have worked your way inward eventually to eventually get what's half of that. 377. Okay. So that's why that works out. And if you're ever unsure, you can run it back, but you will know that you messed up if this value is not a whole number. Well, I guess that's not always true, because technically, as long as you're adding up integers, then your final answer should be an integer, right? Because there's no way to add up integers and then you get a not integer answer. So that is one way to check your work. Alrighty. So hopefully this helps. Hopefully this example helps clear things up if you are still confused. And I'll see you in the next video.